Physiologically, a syndrome is a dense, chaotic cluster of symptoms and conditions operating simultaneously within a patient's body. For medical coders, this presents a distinct challenge. You have to translate that complex biological reality into standardized data. The operational reality of the ICD-10-CM database is that it requires rigid, precise, single-axis data entry to function correctly. This creates an immediate tension. You have to map a multi-conditioned physiological web into a strict linear classification without dropping critical patient data. Achieving coding accuracy in this scenario does not rely on clinical guessing. It requires a strict, standardized operational system. That system is ICD-10-CM guideline B.15. It acts as the database's dedicated routing protocol for handling these complex clinical clusters. Guideline B.15 establishes a specific logic pathway for the coder to follow. Following this specific pathway step by step is the only way to prevent systemic errors, like overcoding a chart or underreporting a critical condition. To understand how this works in practice, we are going to build and model this decision tree from the ground up. By following this algorithm, a coder ensures the patient's record matches the specific requirements of the ICD-10-CM database. Accurate coding begins before any clinical deduction takes place. The algorithm starts with the prime router, the alphabetic index. When encountering a syndrome, look it up here first to see if the system has precompiled instructions. Warning tone. Skipping this step compromises your data's integrity. The index dictates the rest of your workflow by generating a clear operational fork in the road. This fork represents two possible outcomes. Either the system has a pre-existing code for the syndrome or it doesn't. You must let the index guidance answer this binary question before proceeding to the next step in the sequence. The alphabetic index determines the entire coding fate of the syndrome. Ignore it, and the resulting code will inherently fail. Let's examine the first scenario. You check the index, and it provides a unique, discrete combination code for the specific syndrome. This path represents a direct, closed-loop solution provided by the database. The instruction for this path is absolute. Assign that single unique code and stop. This successfully captures the entire biological cluster because the system pre-compiled it. Novice coders frequently fall into the kitchen sink fallacy, the instinct to continue coding every individual symptom the physician documented in the chart. Unless the index explicitly instructs you to add more codes, adding manifestation codes here directly violates guideline B.15. In Path A, precision requires restraint. Assigning multiple codes when a single combination code exists creates overcoding and systemic data bloat. Now, consider the alternative scenario. You check the alphabetic index and find no unique combination code and no clear guidance. Encountering this dead end triggers a secondary workflow, the deconstruction protocol. The core mandate is to visually and conceptually break the syndrome down. From here, you assign individual codes for the specific clinical manifestations documented. This approach requires multiple codes to fully capture the patient's physiological state. When the database lacks a prepackaged option, you are assembling the raw data. You are building the story from the ground up. Without a combination code, data accuracy relies entirely on your ability to thoroughly capture and code every piece of the clinical cluster. The deconstruction protocol introduces a final layer of complexity, knowing exactly which pieces of that shattered cluster must be reported. First, you define the integral conditions. These are the expected baseline symptoms making up the core diagnosis. Then, you shift focus to the remaining nodes, the non-integral manifestations. These are documented conditions that are actively present but fall outside the expected baseline of the syndrome. The critical guideline B.15 rule applies here. You must add additional codes to capture these non-integral manifestations. Incomplete coding occurs when non-integral conditions are ignored. True precision requires separating and coding both the expected core and the unexpected outliers. What happens to the patient record when you deviate from this established algorithmic routing protocol? You encounter system failure modes. The most damaging error is entirely bypassing the alphabetic index. Secondary errors compound the damage, assigning multiple codes when a combination code exists, or coding just a single symptom for a complex syndrome.
Finally, failing to distinguish integral from non-integral manifestations during deconstruction. These failure modes create significant discrepancies. They result in overcoding, undercoding, and ultimately corrupt the healthcare information system. To maintain a cleanly functioning logic pathway, we lock this workflow into memory. We use the AMCI MJ-GEM framework. Part 1, Syndrome, start with the system. This ties directly to the vital first step of checking the alphabetical index. Part 2, No single code, build the story. This connects to the deconstruction protocol, guiding you to code individual manifestations. As a coder, success relies on answering two simple questions. Is there a unique code? And if not, what individual conditions make it up? Replacing clinical guesswork with applied algorithm logic guarantees complete, compliant data capture, and that is coding the AMCI way.